Okay, let's start. So what we seen yesterday was what is SSL or why we need SSL. Now we're going to see how do we implement that SSL in real time, or how do we implement it especially for WebLogic. So that's what we're going to see. Um, we're going to use the key tool, the key management tool, that comes along with your JDK. We'll see how using JDK you can create the keys, you can create the key pair, public private key pair, how to create a digital certificate, and where do we store it, and finally how to configure it. Alright, so the first part, the generation of the key, getting it signed by CA and importing it back into that key store, that's the generic part. Configuration is what is specific to a product. So let's first see how to generate a digital certificate and a public private key. So I'm going to log into our server. Go to our location. I'll go to JDK home that we've been using. This is JDK home. In the bin directory is where we have the key tool. That's it. Here we go. So that's a key tool. We're going to use this key tool to generate a digital certificate and a public private key. Now that we're going to use a gen key pair option here. So make sure you have your PDF that I've sent to you, you have it open. The actual syntax of the commands is in that PDF. Just keep it open. This one. We're going to execute these commands. Alright. So I'm generating first thing a digital certificate plus public private key, and I'll store it somewhere in what is called a key store. So key tool, gen key pair, keep the document open in front of you. Key pair for an alias, call this any alias, means this entire digital certificate plus public private key, this entire thing will be a combination. This combination will be referred to by an alias, and this entire thing will be stored in a key store. So if you see this one, this diagram, this is what we are referring. Server 1 is the alias. We're going to generate a digital certificate, put all the information. It also generates a public private key, stores everything into a Java key store that we're going to give. Now this Java key store is, because this is sensitive information, it has a protection. Now the protection is at the entire store level, which is usually called a store password, and also the private key is protected using a key password. So there are two levels of protection for this key store. One is overall store, protected by a store password, then the key itself using a key pass. Alright, so we are going to create for alias, so call that alias any name you want. Let's say encode IT1, encode IT.in, let's say that's alias. Then key store. Where do you want to store it? Key store. So let's give home and code IT students online. It's overwriting. Key tool -gen key pair line continuation -alias encode IT dot in -key store encode IT student online. Let's say key store.jks. Alright, this gets created now. Line continuation. Then this store is protected at two levels. One is store pass, give anything. Usually the store pass is change me. This usually gets changed. This is a default password if you see, but in our case there is nothing like, there is no ks.jks, so there is no default password. You can give anything you want, so I'm giving change me. Then the second level password key pass, I'm giving the same thing again. You can give a different one, but just to keep it simple, I've given both the passwords here. Alright, that should do. So we are generating a digital certificate plus public private key that gets stored with an alias name. This one in this key store, and the key store is protected with this password, and key itself is protected using key password. So now if you execute this command, it's going to ask you for all the information that we want to put in the digital certificate. Because digital certificate, as I told you, it's an identity card. A digital certificate will simply have all the information just like an identity. What's your name, to which company you belong, what's the location, state, country, all that stuff. So you will see those details here coming up. So what's your first and last name? That's a question. So let's give anything. So let's say encode IT. What's the name of your organization unit? Let's say IT department. Name of your organization itself. Code IT.in. Name of your city or locality. At the bottom, name of your state or province. AP. What's the two-letter country code for this unit to India? So these things are your digital certificate contents. Now initially what you are generating is a self-signed certificate. If you go to a CA is going to validate all these details and certify those details, which will become a CA certified digital certificate. Enter. Alright. So this is a confirmation. Is your CN is common name. Common name is what was asked here, first and last name. So common name and code IT, organizational unit, organization, locality, state, country. Is it correct? Yes, it's correct. Done. So your digital certificate created, stored in this one. That store is protected at two levels using this one, and the alias that we use is this one. Next thing is this key store itself can be listed. If you see this one, that's the key store just now created at 522. Alright. Now if you want to list the contents of the key store, you can do that using the same key tool. Key tool -list -key store, the key store name. Because that's a key store, you're going to give a store pass. Change me. Now that lists everything. Now if you see this one, it has a list. It's a Java key store provider is Sun Microsystems. Your key store contains one entry. This is that entry, encode IT.in. Obviously the private key is not listed. It simply says a private key. Now what, using a list command, what we are getting is how many aliases are actually stored in this key store. Now just like the one that we have created encode id.in that alias. You can create as many aliases as you want and store it into the same key store. So let's go ahead and quickly create another alias. So gen key pair. This time I'm going to create another alias encode id1.in. I'm using the same. Yes. Yes,
so
yes.
what was the last thing that came for the MD5 and big stuff? That was the public key?
No, this is called what's called the fingerprinting. It's usually the checksum kind of thing. What usually happens is, you know the checksum concept? Let's say we are transferring file between, yeah, if you know the checksum is calculated using MD5 algorithm. Checksum can be calculated using lots of algorithms. MD5 is the algorithm that is here, calculating the checksum. So what happens here is, on one system, if this is a checksum on this system, if I transfer this key, transfer this file to another system, calculate the checksum on the other system also, it should give me the same thing. It basically proves that my file has not been tampered with. So this last entry has nothing to do with the key store or key pair. It's more like the integrity of the file. MD5 is the algorithm used to create this entry. It's an algorithm used to generate the checksum. This is not the public key. We can list the public key. We can print it out of that key store. That's possible by exporting the certificate, but this is not that one. All right. So let's go ahead and finish creation of second alias. Again, this also same stuff goes on in code IT. Name of your organizational unit, let's say IT organization unit. Code IT dot in, name of the city, Hyderabad, state AP, country India. Yes. So this again one more thing. So now you can actually list it again. Store pass. If you don't give store pass, it's gonna ask you for it. Key store does not exist. I think we gave the path wrong. Home and code IT. Students online. Check yes. If you don't give the password, let's say, it's gonna ask you the key store password. Alright. Now you see there are two entries. One is the second alias we have created. Other one before that one we had created first alias. So a key store, which is in this case the ks.jks, can store as many number of aliases as we want. Usually in real time you have a single key store, you copy that file everywhere and you have all digital certificates plus public private key entries in the same key store. So we'll refer to them using aliases. So each alias represents a DC. This one, each alias represents a digital certificate plus a public private key pair. Everything stored in that. Alright, now what we have generated is a self-signed certificate. So this has all the information plus the public private key, but it's self-signed. It's not authenticated or verified by anybody. Now ideally what you would want is you want to get this digital certificate that you have stored here. Alright, export it out of this key store, send it to a certifying authority so that they can authenticate your information. Now when you export this and send it to a certifying authority, they would want it in a proper format. All certifying authorities expect the digital certificate in a specific format. Now that format has to be generated by us along with the digital certificate, we have to send it to the certifying authority. Now that format is generated using what is called a certificate signing request. So if you see it here, a certificate signing request. After we have signed a self-signed certificate, after we created it, now what we are doing is you're generating what is called a CSR, certificate signing request. Where is it? It's not that. Yeah, a CSR. This is what it is: certificate signing request, CSR. This is basically a specifically formatted way of sending our digital certificate to the certifying authority. Now we have to generate this certificate signing request, store it in a file, and the CSR we will send it to the certifying authority. We will send it to the certifying authority in a way. It means you send it through email, or you go to their website and paste the CSR. It will be asked. I'll show you. So first thing, in the process of creation or in the process of getting your certificate signed, the first thing you would need is a certificate signing request. So after your self-signed certificate is generated, what you're going to do is you create a certificate signing request. Now that is done using certrec, certificate signing request, or certrec. Now we are creating a CSR. Obviously you're going to store it in a file. Let's say here, store it in a file, code IT online. Let's call that file with some names. Let's say send to verisign dot certrec. A certrec is not mandatory. That's usually how we store it, so that we know, okay, it's a CSR file. Now we are storing it in this one, and we are creating that CSR for an alias encodeit.in. This alias is stored in this key store. This is the key store where it is stored, right? And to access this key store, give the passwords. Store pass chain में key pass chain. That's it. So your CSR is generated. You can see the CSR. This is where we have stored it. So if you do lsfnl, that's your CSR. You can do a cat. This is your CSR. Begin a new certificate request and a new certificate request. So this is what we're going to send it to VeriSign or Entrust or anybody. So the moment you try to buy or buy a CSR, the moment you try to buy a SSL, what that you are doing is you have already generated a self-signed certificate. Out of that self-signed certificate, you have you put that self-signed certificate in a proper format. Then you have generated a CSR. That the CSR is what you're going to send it to a certifying authority. Now go to any website you want to. Let's say we'll go to one of the websites. I'll give you a briefing of what needs to be done. Let's say you go to entrust.com. You're trying to get your certificate signed by a certifying authority. You have so if you see it here, you want to buy now. You click on buy now. And now let's say you have a lot of packages. These are the various types of packages. Now this is a duration for which you want one certificate. I said this is the price. We'll just see, the CSR part. I'm not going to buy anything unless you guys have some money lying around. Now you see this thing? Paste certificate signing request obtained from your server. This is what we are interested in. So you're going to paste it here. You take this thing. Alright. Go to their website. Paste it. Alright. Now once you pasted it, you move ahead with your rest of the things. Now on the next subsequent screens, you will be asked your details and your email ID, everything. Now what they do is they take this certificate signing request which has your digital certificate, they authenticate all that information, they check all the records, kind of, they check your company records with some register of companies, or they validate, they call your office and they see if you have that physical presence or not. So they're going to basically validate all the information given in that digital certificate is correct or not. Once they validate it, then they encrypt this information with their private key. After they encrypt their information in the private key, they send us a similar key, not exactly this one. They will send us a similar key to our email ID. So what you will get is pretty much similar one, not exactly this one, that we will have begin of new key, end of key. Now exactly like this. So you're going to take that content that you got from into your email, you're going to paste it somewhere. Alright, let's say you paste it into your file or something, let's say vi some file.txt. Alright, now once you pasted it, so you have a key that you got from VeriSign. Now that you are going to import it back into the key tool. So import it back into the key store. So what you currently have in your key store is a self-signed digital certificate. Out of this, you have generated a certificate signing request. You sent it to VeriSign or Entrust. They have validated it. They sent you back a key similar to this one. Now this key, you put it into a file, and that file you will import it using the import command. This thing, last thing. Once you import it, the import command is pretty simple again. So if you see the key tool, so it's going to be like this, key tool. We don't have a key from the VeriSign, so I'm just going to show you the command here. Import from this file. Alright, let's say you got this file from or key from VeriSign. It's a text file or something, wherever you have stored it. Then for this alias encode it.in, you store it in this key store. You make sure you import it into the same key store. It will override the self-signed certificate with a CA signed digital certificate. Now key store, you give the key store, and when you are importing, you will give the store pass and key pass. Alright, this part I cannot do now. We don't have a key from that VeriSign, but that's the process. You simply import it back into the key store. Now once you've imported it, you have a CA signed digital certificate stored in the key store. So your process is pretty simple process. You generate a self-signed certificate, you generate a CSR, send it to the certifying authority. Whatever you get back from the certifying authority, you import it back into the key store. When you import it, your self-signed certificate gets overwritten with a CA signed certificate. That's it. This is the process of getting or buying an SSL. Now once you have the SSL certificate, you can configure it to any server you want. You can configure it to WebLogic, WebSphere, Apache, anything, because you already got the certificate. Now what we will see is how to configure it for WebLogic. Now normally when you configure things for any product, let me give you that. I think I have one other document missing. Yeah. Okay. You've seen the steps here already. Generate. This is a gen key pair. When you do a gen key pair, this is what you generate. A self-signed certificate plus the public private key. Everything gets stored as an alias. All such aliases can be stored in your Java key store. In this case, the my key store.jks. Then you're going to generate a certificate signing request. You send it to the certifying authority. Once you get it back, a key, you're going to import the certificate that received from the CA into the same key store. So now you have a CA signed digital certificate. Now once you have it, now we are trying to configure this thing for our WebLogic server. Now here, instead of the CA signed one, we are going to configure a self-signed one itself, because even for a CA sign, the concept is going to remain same. It's not going to change. Now before we go ahead with the configuration, we will see how it is actually implemented in real time. Now what happens in real time is there's a slight change or addition to what we have for the key store. Now if you see, normally every product or every server has two stores associated with it. One store is the identity store, where the alias or the certificate of that product of that server itself is stored. It's something like this. Let's say if I open up a document, let's say I'm the server. This is my server, alright, and this is a browser. Now the communication is happening between these two. Now the server is supposed to produce a certificate. Now the server itself will have its own certificate stored in a Java key store. Let's say this is the Java key store, JKS. Now this is usually called identity store, because this is where the identity of this server is stored. Identity store. Now that's one part. So when the browser asks for the digital certificate from the identity store, the server will pick up its own certificate and produces it. Just this way, just like the communication is happening, this server will also be communicating with others. Let's say there are a couple of other servers here. So this is another server, this is another server, this is another server. Now this server is also communicating with these servers. Now when this communication is happening, what we have is, this guy is the receiving end, this guy is at the sender's end. Now when the communication starts, SSL communication between this and this, it's the right side box that's supposed to produce a digital certificate, which it will produce from its own identity store here. Like this, everybody will have their own identity store. They have their own digital certificate stored. So here we are looking at a scenario where, yes.
Before you were talking about the key store, and now you are saying identity store. They are one and the same thing?
Yes, that's right. The same key store we are now calling identity store. We just changed the name because this is where the identity of the server is stored. Identity store itself is key store. So normally whichever key store our server store their identity, we call them in general, in practical words, identity store. When we say identity store, it's simply just a key store which stores the your digital certificate plus public private key under an alias name. Now if you observe this one, this server has its own identity store from which it picks up its certificate and sends it across to your browser when asked. This server also has other servers which it is communicating. Means this server asks for the certificates from these three guys. Now let's say this communication is happening back and forth again and again. Now when this is happening, a first time when this server talks to, let's say this server name is A, when it talks to server B, it validates the certificate of server B. Now the second time when the communication is happening, let's say this communication is happening between A and B. A is the guy who is asking, B is the guy who is responding. Now B has produced the digital certificate first, A has validated, it said everything is fine, let's communicate, so the communication happened. Now the second time they are communicating, A asked to produce the identity. B has produced the same digital certificate that it has produced earlier. Now do I need to validate the same certificate again? If you are A, let's say, does A need to validate the certificate again, or it's not necessary? The same certificate is produced again by B. This is a question for you guys. You can type in the answers. So does B or do B need to produce the certificate? No, B produced it. A, does it have to validate it again?
No.
Not necessary, right? So because it was already done.
I think the A should store it somewhere that this guy B has come before and he's good.
Right, that's right, exactly. So A can store the certificate somewhere. Now that storage is usually called a trust store. Trust store. This is also a key store. Stores the digital certificates. In the trust store, A is going to store the certificate of B because it was validated. A found everything good with B. Next time when this communication happens, B will produce the certificate again. Say it's not that he's not going to produce the certificate. B will produce the certificate. If that certificate is already there in the trust store, the validation part will be skipped. We're not going to validate it again. The validation process skips because we have already validated the same certificate. If B produces a different certificate, it will be as usual. Validation will go on. So what we are bypassing here is the validation part which was already done for previous certificates. So like this, A will have an identity store. A will have a trust store where all its friends' digital certificates are stored. B, C, D, E means to whatever servers that A is communicating, all those guys' identity certificate is stored in a trust store. Now apart from this, A will also have a CA certs file. The CA certs file will give the list of authorities that A can trust. Just like a browser had a list of authorities, A will have a list of CSR. The CSRs will actually come with the JDK itself. When you install JDK under security lib directory, you have CSRs file. So it's not exclusive to this server, it's common to every JDK. So what is exclusive to this A server is its own identity store, where its own certificate is stored. If somebody else like a browser Greenbox asks, A will produce it. A also has a trust store where its friends' certificates are stored. Now out of all these things, which are mandatory, which are optional? Is identity store mandatory?
If it's a server, then yes.
Yes.
But if it is just
Yes.
a client, then no.
It may not. Yes. Then is trust store mandatory?
Well, yeah, because if you would like to store the people who have come to you in the past, so then yes, not must, but yeah, I mean, very, very nice to have.
Yeah, so it's not mandatory. If I don't have a trust store, I'm going to validate again and again. It's only going to increase my processing thing. But trust store is not mandatory, but it's nice to have because I don't have to redo the same thing again and again. Now CS certs, is it mandatory? What happens if I don't have
Yes.
it?
Because CS Certs has the list of all the guys who are trusted. Unless I have this one, then whosoever is sending me the key, I cannot validate that this key is coming from a valid source or not, basically.
That's right. That's right. So here you will see identity store and CS certs being mandatory, which you will have with every server. Trust store is optional. Now, but you know, for a Java based application or two applications that are talking to each other, you need to have the trust store on both sides. Otherwise, they are not going to trust each other. So the communication will stop uh, for a manual intervention, which is not possible. So if two applications have no interactive mode.
Anil, a question here.
Mhm.
Anil, this authentication between A and B as servers will only be required and happen if they are talking via HTTP port 80. If they're using another port, then no, right?
No, any protocol. If they are using SSL, they will, unless they can have IOP or RMI, any protocol over SSL, any transport protocol. HTTP is one type of transportation protocol. You have RMI protocol, another transportation protocol.
Right.
So that also, any transportation protocol, if you want secure way, it goes through the same process. And we will see the list of protocols.
So if there is a SFTP, even then is required.
FTP, yes. It's FTP works more on, no, it works on a public private key method, but that's not SSL. It works on SSH keys. There is a SSH key mechanism. SSH key uses public private key RSA algorithm, but that's not SSL.
Okay.
That's little different. SFTP, that's secure file transfer, but that works on SSH keys. If you want to know about SSH keys, I think I published a post somewhere. I will give you a link to that SSH keys, this thing.
Thanks, Anil.
It's little different from SSL.
Okay. Thank you.
So here what we have is, if A is our server, let's say we are the administrator of this A server, the eBay server. The browser is a green box. If the browser asks for a certificate, we have to pick it up from the identity store. The server has to pick it up from the identity store and give it. If eBay is talking to other servers, the servers list their own certificates can be put into a trust store. Then CS certs is obviously there with the JDK. So now what we are going to configure is this. We already have this identity store because that's where our our alias is stored, the keys.jks. All that we have to do is tell our server about this key store. That's it. It's very simple. I'm going to put it in a very simple method. Go into your WebLogic, tell your WebLogic somehow, see, this is the key store I have, ks.jks. Use that key store. Inside that key store, there is an alias called encodeit.in. If somebody asks you for a digital certificate, just pick up this digital certificate, give it to that somebody. That's it. Very simple process. A creation of the certificate is little. Again, that's also simple once you understand what you are doing. So after it's created, configuring is much more simpler. So what you have to do is, any product, this configuration is common for any product, not just WebLogic. To that product, you have to tell only two things. The key store location, inside the key store, what alias it's supposed to use. That's it. We're going to do that. Before we do that, means before we configure our WebLogic with the key store, identity key store, we have to make our WebLogic able or capable of receiving SSL request. A WebLogic or any other process cannot listen for HTTPS type of requests on a regular port. If you take, for example, our own tools. Let's take, for example, our own server. Here, BA10G user underscore projects, domains, and code daemon. Let's say I will start our admin server. jlfnfadmin.log. Now this server is listening on port number 9001, I think. So it listens for the regular protocol or the HTTP, IAOP, all that kind of. Let me show you. See this thing. You see this thing? Channel default is now listening on this IP port for the protocols. These are the protocols. It listens for IAOP, T3 protocol, LDAP protocol, SNMP, and HTTP. This port itself does not have any capacity to listen on the secure list. Means when somebody sends a request, HTTPS request, it cannot understand on this port. So your WebLogic server should have a separate. Just give me a moment, guys. Let me take a call. Okay, sorry. So this server is listening on 20001 port for regular messages, not the secured messages. Now what we have to do, the first thing is make your server capable of listening HTTPS request or IAOPS request. That's pretty simple. So what we're going to do is I'm going to log into the console, enable the SSL port, the first thing. So let's log into the console. Install 168.128.6 2001/console. WLS admin, WLS admin. Alright, now it's very simple. You go to servers, enable the SSL port. Servers, let's say we are enabling the SSL port on let's say manage server 1. Then we have to start the manage server 1. We will start it. So this is manage server 1. If you see this one, listen port enabled is a regular port. This is SSL port. It's pretty simple. And if you see, there is no error mark here. Error mark means requires a restart. That's what an error mark means. If you change the property that has a error mark on the console, it actually says that restart may be required. See that thing? So it's a standard rule. You see error mark, you restart it. Here in our case, SSL, it doesn't have any error mark, which means you can on the fly enable the SSL port. Now the server is not running, so I'm not. Okay, instead of 7002, let's put 20011. Usually the SSL port is the next port to your regular port. 20010, I'm putting 20011, save it. Now the same way I can do it for admin server. That will be much more visible. Let's say I do it for admin server. Let's look at the log file. Currently our server is listening for regular incoming requests on this IP port. We're going to add additional port. This port will continue to run. We're adding an additional port. Alright, SSL port 20,002. Save it. Now your server is ready with this thing 20,002, and it's listening for IOPS secure, T3S secure, cluster broadcast secure, LDAP secure, HTTPS secure. So your server is ready to listen for HTTPS request, but which means your server is ready with SSL. The moment we say it's ready with SSL, obviously it has some kind of certificate to produce. In this case, WebLogic comes with a demo certificate. The moment you enable SSL, it produces a demo certificate which is stored in what is called a demo identity.jks key store. You see this? The moment we enable, these things happen. These three things. What are those three things happen? See this thing. Loading the identity, it loads the identity certificate and the private key store. This is the alias name it uses, demo identity, and this is the key store, demo identity.key store. Along with the identity key store, it also has a trust key store called demo trust.js. Both are available in WL home server lib directory. Then it also stores a CS cert certificate. Now once these three certificates are loaded, it's ready to listen for incoming requests on HTTPS. Now that this is an admin server, we can actually talk to this admin server using HTTPS and ask for the console. See this thing, HTTPS. Now for this demonstration, I'm going to use Firefox to give better view. Let me use Firefox. Oh. I just said Firefox. Alright, now let's ask for the digital certificate from our server. Now remember, our WebLogic admin server is equipped with SSL port, which means it can respond to HTTPS request. Now the browser is sending an HTTPS request. The moment we send an HTTPS, we mean that produce a digital certificate, irrespective of what piece we are asking. In this case, because it's an admin server, we're going to simply ask for the console piece. So here, if it is a managed server, we can ask for a application related page, but because it's an admin server, I'm going to ask for a console page. But this page I'm asking using a HTTPS request. The moment the server sees HTTPS request, it's supposed to produce a digital certificate. Now the digital certificate, our server will pick it up from the demo identity key store with an alias demo identity, and it's going to produce to us. When it's produced, our browser will try to validate this certificate. It will try to see if this certificate was signed by anybody or any authority in its own list. If it cannot find in its own authorities list, it's going to give us an alert. It says, I tried to compare or I tried to validate this certificate, I could not find an authority who issued this certificate. So what do you want me to do? This is the wrong port number. We are supposed to give 2002. That's our SSL port. Can you guys put yourself on mute? Yeah, thank you. So here we have an SSL port. So this is where we have to send SSL request. You cannot send SSL request on a regular port. This is a regular port. Let's send it on 2002. Now, see this one. What happened here was browser has sent a request to produce the certificate. Now here the communication is not happening yet. We're not talking about our, the browser and the server are not talking about console application at all. They are initially at the validation part. A request was sent HTTPS on the SSL port number. When it was sent, the server has produced a digital certificate with this identity, demo identity. When that was produced, see this one, I think you got a message also here. Unknown CA, alert received from, this is my box, the browser running. The peer is rejecting the certificate chain as being untrusted or incomplete. That's this error you are looking at. Our browser has rejected the certificate. Why it rejected? A demo identity, let's see the certificate that was produced. Now, it gives a very nice explanation here, your Firefox especially. See this. This connection is untrusted. Your browser is saying this is untrusted connection. Why? You have asked Firefox to connect securely to this IP port, but we cannot confirm that this connection is secure. See, the connection did not fail. A browser is warning you. What it says is it's not secure. Normally, when you try to connect securely, sites, in our case the WebLogic admin server, will present trusted identification to prove that you are going to the right place. Our demo identity that was produced by our WebLogic server is not a trusted identity. However, the site's identity cannot be verified here because it's not in the list of authorities that the browser actually trusts. Now actually you can go into the understand risk, look at the certificate that was produced, add exception, get the certificate, view the certificate. Now this was the certificate produced by our server. The demo identity alias is this certificate. See this one. This has a common name, encode IT server 10, organization, my organization, organizational unit for testing, serial number. Issued by, this is what has failed. Search uncap. Now our browser tried to see if its authorities list has search uncap. It could not find it. That's why it said, I don't know who search uncap is, so I don't know if I can trust this server. That's the alert message you've seen. Then you got the validity thing, which is, depending on the number of days we give. Alright. So here, again, the fingerprint, this can be verified on this side. This is what we see, Deepak. The fingerprint on server side, fingerprint on the client side. If they both are same, it means our SSL certificate is not tampered with.
Got it.
So here, so what we have done is we are looking at the certificate produced by our server. So the browser has actually rejected the certificate. Now as an end user, we can ask our browser, no issues, go ahead with the certificate. We know that issuer. You can confirm a security exception. It will take you to the actual page. But the SSL communication itself has failed because our server has produced a certificate, which is demo identity, signed by Surgeon Cab or something, picked up from this keystone. Now instead of this, we can configure a custom certificate, the one that we have generated, and we are storing it in ks.gks. Now as I told you, a configuration is pretty simple. We're going to tell about the store, we're going to tell about the alias within the store. That's it. So our server is ready for HTTPS type of request. Now all that we have to do is tell about the store and tell about the alias within the store. So here in this case, Trust store is obviously optional. These two are demo identity.jks and demo trust.js. These are the default stores that you can use. Then let's configure it. Now I'm going to log into the console. Let me go back to the regular port. HTTP 192.168.128.6 20,001 console. WLS admin. Now here, let's say we are configuring it for manage server 1. We have to configure for all the servers individually. You cannot configure at a domain level because it's the process that your client will be talking to. So each process should have this configuration. So whatever we are going to do has to be repeated for all the servers in your domain. I'm going to do it for admin server. Now as I told you, two steps. One is tell the key store. Two is tell about the alias. So you go into that server to whichever you are configuring. Go into key stores. In the key stores tab, currently you have demo identity, demo trust, the corresponding key stores. Alright. Now what we are configuring, instead of the demo, we're configuring a custom identity, custom trust. Now the moment you say custom identity, custom trust, you will see a warning here that you want to change the alias names on the next tab that we are going to do. So custom identity, custom trust, give the identity location. The first thing it's going to ask you is the key store location. So we have a key store ks.js, home and code IT, students, online, ks.js. That's our key store. Yeah, I've reduced it. Is this okay now? Okay, now. So give about the key store. Now key store type. This is a Java key store. So JKS. Now because our server is trying to access the digital certificate which is stored in the key store, a store is password protected. So our server should know about the password. This is the store pass we are giving. So I'm giving that password, change me, CHANGEMA, change me, and confirm that password here. Same password, CHANGE, change. That's it. Now the trust store, you can configure a trust store. You can pretty much configure the same store to be trust store also. No issues. Alright, because after all, the identity key store and trust key store they both are same. You can configure the same thing as trust store, home and code, or you can leave it as you want. Alright, let's say I leave it. You will see actually a message. There is no trust store, so we did not load any trusted identities kind of message. So we're going to configure only identity. Trust store can be a different key store or it can be the same key store. Now this you're saving. Now once you've saved it, so you told the server about the key store. Now the next thing you have to tell is inside the key store what alias it has to use, because there are multiple aliases in your key store. So go into the next tab, SSL tab, tell about the alias identity. That's it. So here in our key store you have encodeit.in. Let's say that's the alias we want to use. Now once the digital certificate is produced, let's say the trust is established, your browser is going to send encrypted information. The encrypted information needs to be decrypted. For the decryption, our server is going to need the private key. Obviously the private key is protected using a key pass. So here what you are giving is the key password or key passphrase it's called. So in the previous screen you have given store pass. Here you are giving key pass. Now just to avoid confusion, what we really do in real time is we give the same password for both, store pass and key pass. So whatever password it's asked, you don't have any issues. But conceptually, that's what it is. This is the key pass, which protects the private key. In the previous screen, we have given the store pass, which protects the entire store. And once you're given the alias information, that's it, save it. You're done. You're ready now. Now this certificate, new certificate, should have been loaded already. Now you see this thing here? Yeah. Loading the identity certificate and the private key store under the alias encodeit.in from the JKS key store file, this key store. So our identity is loaded. Then this thing, no trusted certificates have been loaded. Server will not trust any certificate it receives because we don't have a trust store. Then we are ready. Our server is ready to produce a custom certificate now. Now let's try it again. So come out of this thing. Again, trust, send HTTPS request. This time it's going to produce a new certificate, and that certificate also will not be trusted by the browser because that certificate is generated by us. It is not certified by a certifying authority. So it's a self-signed certificate. But we will see the certificate. 20,002 console. This connection is also untrusted. Again, the same thing. Your server has produced a certificate. I could not validate it. That's what your browser is saying. Go into exceptions, get the certificate, view it. Now you see the certificate. This is a newly generated certificate. A common name and code, IT, organization, this thing, IT department, serial number. Issued by, again, us. This is a self-signed certificate. Issued to, issued by, it's same thing. Now obviously, the issued by thing could not be verified by the browser. So the browser is again saying, I don't know who this encode IT is. Who is this guy who is certifying this or issuing this SSL certificate? So your server is now capable of responding to SSL requests. But obviously, the browser, again, it's rejected. See this thing? This is a request. Bad certificate alert was received from the box. Our browser has actually rejected the certificate. That's the error message you will see. It's a warning more of. So our server is now capable of responding to SSL requests. Now what we have configured is a self-signed request. Now in case of a CA signed one, the only difference would be importing. The one thing that we could not do here is importing the certificate or the key that you got from CA into your email. You will import it to the key store and the rest of things will remain same. Now normally if it is between two applications where there is no interface like a browser interface where you cannot confirm or add exceptions, you simply have two applications. The certificate of each other will be in the trust store of each other. So application 1 will have its own digital certificate. Let's say there is a single key store. Now it's done really simply in real time, even though it's conceptually little overwhelming sometimes. Let's say if you have two applications, you want to set up SSL between those two, you should do it very simply. Okay, once you know the concept. So let's say this is application 1, this is application 2. Now what you do is this is app 1, this is app 2. Alright, so you have a common store for both of them. The easier way would be, so the demo identity and demo trust, the identity store and trust store, everything is common. So this is the identity store. It's gone, sorry. This is app 1, this is app 2, then you have a identity, trust, or common. So the same thing is identity and trust also. So what you have is the certificate 1 for green box is in here, certificate for the red box is also in here. So both certificates are in the same identity store, but that also is a trust store, which means application 1 trusts application 2, application 2 trusts application 1. That way these two SSL is pretty simple. That's how usually it's configured. Or else an easier and a much another level would be to have two identity stores for two applications separately, two trust stores for two applications separately. You import the certificate of one thing into the trust store of other thing. That way both the applications trust each other, both sides. So your communication will not have any exceptions. Now when you are importing explicitly into a trust store a certificate, you are adding an exception. That's what you are doing. What an add exception does here? In the browser case, our add exception, what it does was simply it stored the certificate of our server into the trust store of the browser. So we said no issues, we know that guy, store that guy's certificate into your trust store, we can trust. The same thing you are explicitly telling between two applications. You store somebody's certificate into your trust store, you're basically telling we can trust that guy. That's how simple it is. Alright, any questions? That's SSL configuration. It's a beautiful concept, and it's really easy once you know the concept. It's easy to set up, it's easy to troubleshoot. Otherwise it gets a little confusing a lot of times. What I would want you to do is probably do the same thing for OpenSSL. Like key tool is one management tool that you can use to generate the certificate and generate CSR everything. Then OpenSSL command is another tool that can be used to do the same thing. Now a lot of documents available online, so because you know the concept, it would be pretty straightforward to go with OpenSSL also. You can go through Google and do it. But key tool is something that's used more frequently. And the configuration of SSL for any product is pretty simple. It's not just WebLogic. The generation of the key, generation of the CSR, getting it signed by a CA, importing back into the key store, it's generic. It has nothing to do with any WebLogic or WebSphere. Once that part is done, all that you have to do is, if your product is XYZ, tell XYZ about the key store, tell XYZ about the alias within the key store. That's it. The configuration of SSL for any product is very simple. Alright, any questions?
Hello?
Yes.
Hi sir, this is Kalyan. So I have one question. Like when you take like two applications, application 1, 2. So as you said, that concept would work when they're deployed on the same server, right? When they share the same demo identity and trust.
Why? You can have it on two servers and configure the same key store. What's the problem?
Okay. So same key store can be configured for the application 1 server and application 2 server too?
Yeah, that's what we're going to do, right? Here all your managed servers should have the same certificate. They can, managed server 1 cannot say my name is uncode IT, and managed server 2 cannot say my name is something else. They all have to say their same name, right? Because they are all behind a load balancer. The request will be distributed.
Okay. Okay.
So all the managed servers should have the same key store. In fact, here they should have the same alias.
So within a server, within a managed server, if there are like a couple of applications, they
You can
can share
also
the
use the same
same.
thing. Yes, yes. You can share the alias among any number of processes. It doesn't matter.
Okay. Okay. And one more thing, sir. Suppose if we like submit the identity digital certificate which is self-signed, but and like normally in some companies when we use our internally, some servers will submit the self-signed.
Yes.
So will the other application or server which receives that submission will throws an error or exception something
Yeah,
like that?
it will throw an error. That's why you have to import your certificate into the trust store of that application. You have to add an exception to that application.
So even though if it is self-signed, we have to import into the trust of other application or server, right?
Yeah, self-signed only will have problem. If it is CA certified, that will automatically detect it because that will have a CA certs file. Self-signed is where you will actually import it into the trust store explicitly.
Okay, okay. So otherwise, it would not be like any
You
use
won't
for
need it
that.
usually, yeah, because that
Okay.
application will already have a CA certs file, and the CA
Mm-hmm.
certs file will have the guy who has certified your certificate.
Okay. So normally we see that SSL handshake exceptions will be like throwing that one,
Yeah,
right? So
if you see XSL handshake exception, import your certificate into that guy's trust store. Whoever is
okay,
receiving, go to that application, pick up the trust store of that application, import your certificate.
okay. So suppose one of the servers, suppose if the app which it hosts are like services, suppose like Java services or SOA services. If suppose the other application which consumes that services, so whatever the request it sends, all the requests should be in like HTTPS, or like it could be some of them like HTTP or HTTPS like that.
It depends on the contract of your service, how
Okay, so
your
it can
register is
be,
defined.
so it can be like divided, right? Like some of the requests could be
Yes,
only
it can.
SSL, and the other
Yes,
would be
yes,
like only
yes, yes,
okay,
it can.
only it can be broken down into parts and it can be consumed, right?
Yes, yes, it can.
Okay, okay. Yes, sir. Got it. Thanks.
Anil,
Yes.
Anil,
Yeah, yeah.
if say I have two physical different server machines,
Hmm.
and they are in one domain, in one cluster, I mean,
Hmm.
then for those two different servers, I need to have the same certificate.
In a practical scenario, that's what you would want, right? Because those two servers are doing the same job.
That is right, but then if I now act little smart in
Hmm.
my company, if I have 10 different servers
Hmm.
doing different jobs, I
Hmm.
can copy paste the same certificate everywhere and save on my money.
No, very Chinese. I don't think they are that kind of naive. They will, map it to the number of CPUs. Yeah, what you said is correct, but it maps to the like a key which you can use for certain number of CPUs only. So they map it.
Okay, so basically when I'm using for two different servers, doesn't really matter because they are giving me for say 16 CPUs and each my machine is still 4 CPU each, I can still use 8 more CPUs
Yes, yes,
somewhere else.
that you can do. Yes, that's right.
Okay. Does it look, and if say I'm using the virtual machines, it will only look the virtual CPUs?
Uh, I think it looks at the physical CPUs.
Okay, which is not right. Anyways, so when you do the this key tool, the key
Mhm.
tool is able to access the number of CPUs we are certifying it for.
Yes, when you are generating a CSR, that's what it actually does. When you export it out of the key tool, it actually puts it. And I think instead of at the key tool level, when the VeriSign is sending our key, that's where they do some kind of mechanism to detect the number of CPUs that we've been using.
Mm, I see
I'm not
because
really sure because how a normal key is verified for the number of CPUs. Let's say you got Oracle license, database license, or some other license. How do they do
uh,
it?
actually it is different. It is, believe me, Oracle is like a salesman, and the smarter you are, you pay less. I have so many clients, but let me answer your question in general. In general, these days Oracle databases are licensed by the number of CPUs. Okay. Now let me give you exceptions here.
Okay.
Your Linux virtual machine is not licensed and certified for any of middleware products. So WLS today is not certified with Linux virtual machine. You know this? It is
No,
just
I
not
don't
certified.
know this. I don't
Yeah,
know.
it is not.
Yeah,
You
it's
cannot
not
buy that
certified.
license.
Yeah, that's
The
right.
way,
Yes.
it is not. So, but if you buy AIX machine, then you can buy the license for the virtual, which in IBM's world are called as LPARs. You can, in that the virtual is possible, and you can buy the license. On top of it, you can buy the license for the virtual CPUs.
Oh,
You know
okay,
what I'm
okay.
saying now?
Okay. Yeah, I got it.
So it is very tricky, but I think I'm just trying to give you an overview.
Yeah, I think we can, even in that case for SSL also we can find some, workarounds that will bypass the licensing terms. I'm sure that can be done.
Because technically you have a point that if say physically I have two machines serving one domain, one cluster,
Right.
then I would like both the machines to use the same certificate, otherwise I will be in problem.
Right.
Right? So that's what. But anyway,
Yeah. I think it
I
can be
understand.
done. I think it can be done. The workaround can be found. I don't think it
Okay, no
cannot.
problem. Thank you, Anish.
Yep.
Hello.
Yeah.
Hello. I have one more
Yes.
question.
Yeah.
Like in like front end web server, like how will it be like configured the SSL certificate, sir, when it bypasses the web server? So where will be configured the SSL in web servers?
Apache, you have to configure in httpd.conf. That you
Okay.
have to, enable SSL. The first thing is Apache is little tricky. There is a bug in Apache that actually, when you are installing from the source code, you have to enable SSL first thing. You have to compile the code using SSL. Then there is a SSL enable tag. You have to enable it. Then the same process. You tell about the key store. You tell about the alias within the key store. The
Okay.
process is
So
same. All the configuration goes into the configuration file httpd.conf file.
okay. So it will directly reroute to the application server. That's it, right?
That's it.
Oh, so we don't use like demo trust and demo identity in web servers, right?
No,
Or do we
demo
use that?
trust is for WebLogic. Why we have demo trust is, let's say you have two applications which are internal to the company. Now in that
Okay.
case, you don't need trust part. You need encryption part.
Okay.
What happens is, step one, trust between two applications, you don't need it because those two are internal applications, or both the servers are within your own company. So you go ahead with demo certificate. Even if you are using the demo certificate, you will still be able to achieve the encryption part using the public private key. So that's when you go ahead and use the demo identity keys.
Okay. So in web server, we just like tag that SSL enabling in the http.config and it will reroute to WebLogic, right?
No, SSL is between browser and web server in that case.
Browser and web server.
See,
Okay.
you
So
can have browser to web server SSL. Again, web server to WebLogic. Again, you can configure SSL. See, SSL is between two parties. Whoever is talking, it's between them. Now, your question is browser and web server talking to each other, or is web server and WebLogic talking to each other? Where do you want the
web.
SSL? You can put it anywhere you want.
Okay.
It's
So
very
as
simple. Two guys talking to each other. You want security, you put SSL. That's it.
okay. So as we have seen now, like you have enabled HTTP, we use HTTPS, and from the end user perspective in the browser, we are using that, and we are giving the IP port of managed server, right?
Yeah, my communication is between browser and the managed server,
Okay.
admin
So in
server in
between
this case.
we don't have any web server like that.
No, I don't have anything. I directly hitting that admin server, right? IP port of that. I'm not contacting the web logic, web server
but
anyway.
like in real time, as you see, like we will definitely have a proxy server, right? So in between.
Yes, you will have. In that case, HTTP has to, your web server has to be configured with SSL, Apache.
Okay. Okay.
A lot of
So
times you will
normally,
have WebLogic, and HTTP and WebLogic will also be talking in SSL. Means your Apache server and WebLogic will be talking in SSL. That's what you will do, the way we said it.
okay. Okay. So whatever the concept you have seen between directly and browser to WebLogic, it works like browser to web server and even web server to WebLogic, right?
Yes, that's right.
Okay.
The browser thing we have seen only for testing purposes. The configuration of WebLogic will still remain the same. Why the reason? The reason why we use browser is we want to test things, whether we are getting the correct certificate or not.
Okay. And one more thing, sir, even the admin server and managed server, will they listen on the port which we give, or will it listen on something like 8080 or some 80
No,
on that port?
any process will listen on the port that we give, right? Any
Okay.
process,
So,
even for
but
a HTTP server,
okay.
the port 80 that you said is configured somewhere. It's configured in httpd.conf. It cannot listen on its own. Every configuration has to be there somewhere. So here we have given 20,002. It's listening on 20,002 for SSL.
So in HTTPD, suppose if we give any other configuration, whatever like manually, so it will listen on, only on that port, right?
That's right.
Okay. Okay. Okay, sir. As we see, like normally in web services and all those like schemas, there will be only 80 and 443. So I'm a little bit
Now
confused
those are
about
the
that.
default ports. Those are the default ports. 80 is a regular port. 443 is the SSL port for all web servers. Those are defaults.
Yes, sir. But the thing is, when we hit the application server, when they retrieve the web server endpoint or endpoint results, when they hit it, they will receive a schema, right? So in that, it's directly listening on 80 or 443, but the port which we give in the admin or manage will be different. So how will it be, sir?
No, that will be a redirection in that case. Port redirection at DNS level.
Okay.
You send it to DNS, you say it's 80. Your DNS is told something like, if you get a request on 80, send it to 8080 or 7080. So on the back end, you will have some other port. A front end request, the user will send it to a different port. Then you will have to have a translation kind of thing, which which happens at DNS.
Okay. Okay. So even on the application server also, it listens on that port. So it will be configured in the load balance and stuff itself.
It can be done, yes.
Okay. Okay. Yes. As like it is a little bit tricky, sir. Apache is like I'm like a little bit confused.
Apache is, yeah, it's vast. It's vast.
Yes.
Apache is too large.
Okay. Okay, sir. That's fine. Yeah.
Okay, cool.
Thanks.
Any other question, guys? Channa or Krishna, any questions? Otherwise, you guys can disconnect. Yeah. Yeah.
Anil, I would like to quote what Deepak was saying in case of multiple servers in a domain and in a cluster environment.
Mm-hmm.
I have the doubt like the SSL can be configured on domain level or on each server level.
Each server. Each server.
Each server.
Yes.
Okay. Then okay. The next question. If it is on each server, then let's say I have managed server 1, managed server 2 in a cluster. I have configured SSL on managed server 1, not in managed server 2. So if in a cluster, like I got a request and I made a request to the managed server 1 with that secured URL. So in some point of time, managed server 1 was down. So obviously, I need to redirect to the managed server 2, which is not configured with the SSL.
You are going to have problems. That will cause problems. That will cause lots of errors and unpredictable behavior. Most likely, the communication will terminate.
Okay. So that means
that's a valid question.
all the managed servers. Yeah, all the manual servers should be configured with the SSL then in
That's
that
right.
in the cluster.
That's right. That's right.
Okay, is there any difference in production and development? It is configuring the SSL?
Production mode and development mode?
Yes, yes.
No, there is no difference. There is a difference in terms of using the demo certificate. In development mode, if you use demo certificate, it won't throw out any errors. But in production mode, if you use demo certificate, it's going to throw warnings. So other than that, SSL itself has no difference in terms of configuration. It's the use of the certificate that gives you warnings in production. If you are using the demo, it will tell you are using demo, you should not use it for production mode.
Okay. So any other changes in Fusion middleware configuration?
What is it, Chana?
Fusion middleware in Fusion middleware application. So is there any
For
difference
SSL?
in the configuration? Yes.
No, same. WebLogic
Okay.
we are talking, so anywhere WebLogic is same. If you are talking about composites, then you have to have a policy kind of thing, SSL based policy that you will attach to a composite. That's a different story altogether.